Hello there, and welcome back to another peaceful journey through the universe. Tonight we're going to drift slowly through the cosmos, exploring 100 gentle facts about space, stars, galaxies, and the vast, beautiful darkness that surrounds us all. There is no urgency here, no need to remember anything. Just let each fact wash over you like waves on a distant shore, soft and rhythmic, carrying you deeper into rest. The cosmos is patient. It has been here for nearly 14 billion years, and it will be here long after we close our eyes tonight. So settle in, let your breathing slow, feel the weight of your body sinking into comfort, and if you enjoy these journeys into sleep, feel free to like and subscribe, or simply rest and let the universe hold you. But for now, let the cosmos unfold around you, fact by fact, star by star. And if you're ready, let's begin. Fact 1. The universe is almost 14 billion years old. Scientists have measured the age of the cosmos by studying the oldest light we can see, the cosmic microwave background, a faint glow left over from the Big Bang. The universe was born 13.8 billion years ago, give or take a few 100 million years. That is an almost incomprehensible span of time. If you compressed the entire history of the universe into a single year, with the Big Bang happening at the stroke of midnight on January 1st, humans would not appear until December 31st at 11:58 p.m. Our entire recorded history would fit into the last few seconds before midnight. We are newcomers to this ancient cosmos, and yet here we are, able to look back across billions of years and piece together the story of how everything began. Fact 2. The universe is expanding. Every galaxy beyond our local neighborhood is moving away from us, and the farther away a galaxy is, the faster it is receding. This discovery, made in the 1920s by Edwin Hubble, revealed that the universe is not static but dynamic, growing larger with every passing moment. Space itself is stretching, carrying galaxies along with it like raisins in rising bread dough. This expansion means that the universe was smaller in the past, much smaller, and if you trace it backward far enough, you arrive at the Big Bang, the moment when everything began. Fact 3. The Big Bang was not an explosion in space. It was an expansion of space itself. Before the Big Bang, there was no space, no time, no matter, no energy. Everything that exists came into being in that first moment. Space and time were born together, unfolding from a state of unimaginable heat and density. Within the first fractions of a second, the universe expanded faster than the speed of light, a period called inflation. Within the first few minutes, the first atomic nuclei formed. Within the first few 100,000 years, the universe cooled enough for atoms to form. And from that point on, the cosmos began to take on the structure we see today. Fact 4. The oldest light in the universe is still reaching us. It is called the cosmic microwave background, and it is the afterglow of the Big Bang. This light was emitted about 380,000 years after the universe began, when the cosmos cooled enough for atoms to form and light to travel freely for the first time. Today, that light has been stretched by the expansion of the universe into microwaves, invisible to the human eye but detectable by radio telescopes. When scientists map the cosmic microwave background, they see tiny variations in temperature, ripples that represent the seeds of all the galaxies, stars, and planets that exist today. You are looking at a baby picture of the universe, a snapshot from when it was only a fraction of its current age. Fact 5. The universe is mostly empty space. If you could remove all the matter from a galaxy, all the stars and planets and gas and dust, and spread it evenly throughout the galaxy's volume, there would be less than 1 atom per cubic meter. The distances between objects in space are so vast that most of the universe is simply emptiness, a void through which light travels undisturbed for billions of years. This emptiness is not hostile or cold, though. It is simply space, the stage on which the cosmic drama unfolds. Fact 6. There are more stars in the universe than grains of sand on all the beaches on Earth. Estimates suggest there are about 100 billion trillion stars in the observable universe, a number so large it defies comprehension. That is 10 to the power of 24, a 1 followed by 24 zeros. If you tried to count them, 1 per second, it would take you trillions of times longer than the current age of the universe. Each one of those stars is a sun, many with their own planets, their own stories, their own possibilities. Fact 7. The observable universe has an edge, but not because the universe ends there. The edge exists because light has only had a finite amount of time to reach us since the Big Bang. Beyond that edge, there is more universe, but we cannot see it because its light has not had time to arrive. The observable universe is like a sphere centered on Earth, with a radius of about 46 billion light-years. But the actual universe, the totality of everything that exists, may be much larger. It may even be infinite. Fact 8. Light takes time to travel. So when you look at distant objects, you are looking into the past. The light from the sun takes about 8 minutes to reach Earth. So when you see the sun, you are seeing it as it was 8 minutes ago. The light from the nearest star, Proxima Centauri, takes 4 years to reach us. The light from the Andromeda galaxy takes 2.5 million years. The farthest galaxies we can see are so distant that their light has been traveling for more than 13 billion years. We are seeing them as they were when the universe was young, only a few 100 million years old. Fact 9. The speed of light is the ultimate speed limit in the universe. Nothing can travel faster than light, which moves at about 300,000 kilometers per second. This is not just a practical limit. It is a fundamental law of nature, built into the structure of space and time. Einstein's theory of relativity shows that as an object approaches the speed of light, its mass increases and time slows down for it relative to the outside world. At the speed of light, time would stop completely. This speed limit has profound consequences. It means that even with the fastest possible travel, it would take years to reach even the nearest stars. Fact 10. Time is relative. It passes at different rates depending on how fast you are moving and how strong the gravitational field is around you. This is one of the strangest predictions of Einstein's theory of relativity, and it has been confirmed by countless experiments. A clock on a fast-moving spacecraft ticks more slowly than a clock on Earth. A clock near a black hole where gravity is intense ticks more slowly than a clock far away. Time is not a universal, unchanging flow. It is flexible, warping and bending depending on your motion and position in space. Fact 11. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse at the end of their lives, compressing so much mass into such a small space that the fabric of space and time itself is torn. At the center of a black hole is a singularity, a point of infinite density where the laws of physics as we know them break down. Around the singularity is the event horizon, the boundary beyond which nothing can return. Once something crosses the event horizon, it is lost forever, pulled inexorably toward the singularity. Fact 12. Black holes are not cosmic vacuum cleaners. Despite their fearsome reputation, they do not roam through space, sucking up everything in their path. A black hole's gravity is strong, but only if you get very close. If the sun were suddenly replaced by a black hole of the same mass, Earth's orbit would not change at all. We would continue orbiting at the same distance, in the same way. The only difference would be that we would no longer have sunlight. Black holes only affect objects that come very near them. From a distance, their gravity is no different from any other massive object. Fact 13. There is a supermassive black hole at the center of nearly every large galaxy. These black holes are millions or even billions of times more massive than the Sun. The one at the center of the Milky Way, Sagittarius A star, weighs about 4 million solar masses. Despite its enormous mass, it is surprisingly quiet. It does not consume much material, and it does not emit much radiation. It simply sits at the heart of the galaxy, a dark anchor holding everything together. Other supermassive black holes, in other galaxies, are more active. They consume vast amounts of gas and dust, releasing tremendous amounts of energy in the process. These are called active galactic nuclei, and they can be so bright they outshine all the stars in their host galaxies combined. Fact 14. The first image of a black hole was captured in 2019. It showed the supermassive black hole at the center of the galaxy, Messier 87, about 55 million light-years from Earth. The image revealed a bright ring of glowing gas surrounding a dark shadow, the black hole's event horizon. It was a historic achievement, the result of years of work by an international team of scientists using a network of radio telescopes spanning the globe. For the first time, humanity had seen the unseeable, a glimpse of one of the universe's most mysterious objects. Fact 15. Neutron stars are the collapsed cores of massive stars, compressed to incredible densities. A neutron star is about 20 kilometers across, no larger than a city, but it contains more mass than the Sun. A single teaspoon of neutron star material would weigh about 1 billion tons. Neutron stars are so dense that their gravity is immense. If you stood on the surface of a neutron star, you would weigh billions of times more than you do on Earth, and you would be instantly crushed flat. Neutron stars also spin rapidly, some rotating hundreds of times per second. When they emit beams of radiation from their magnetic poles, those beams sweep across space like lighthouse beams. And if one of those beams points toward Earth, we see it as a pulsar, a cosmic lighthouse ticking with perfect regularity. Fact 16. Pulsars are some of the most precise clocks in the universe. Their rotation is so regular that astronomers can use them to measure time with incredible accuracy. Some pulsars are more stable than atomic clocks. They have been used to test theories of gravity, to search for gravitational waves, and even to navigate spacecraft. Pulsars are proof that even in the most extreme environments, even in the remnants of exploded stars, nature can create order and precision. Fact 17. White dwarfs are the fading embers of stars like the Sun. When a star like ours exhausts its fuel, it sheds its outer layers and leaves behind a dense core, a white dwarf. This remnant is about the size of Earth, but contains about half the mass of the Sun. White dwarfs glow with leftover heat, shining faintly for billions of years as they slowly cool. Eventually, they will fade to black dwarfs, cold and dark, though the universe is not yet old enough for any black dwarfs to exist. Fact 18. Stars come in many colors. The hottest stars burn blue or white, with surface temperatures reaching tens of thousands of degrees. Cooler stars glow yellow, orange or red. Our Sun is a yellow star, with a surface temperature of about 5,500 degrees Celsius. The coolest stars, red dwarfs, have surface temperatures of only about 3,000 degrees, though cool is relative. Even the coolest stars are hotter than anything on Earth. Fact 19. Red dwarf stars are the most common type of star in the universe. They are small, dim, and burn their fuel so slowly that they can shine for trillions of years. None of the red dwarfs that exist today have reached the end of their lives because the universe is not old enough. They will outlast all the other stars, glowing faintly long after the bright, massive stars have burned out and faded. Fact 20. The largest stars are unimaginably vast. The biggest known star, Stephenson 2-18, is so large that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. It is nearly 2 billion kilometers across. And yet, despite its size, it is not particularly massive, only about 20 times the mass of the Sun. Large stars are puffy and diffuse, their outer layers spread thin. Fact 21. The most massive stars live fast and die young, while a star like our Sun will shine for about 10 billion years. A star 100 times more massive might last only a few million years. These giant stars burn through their fuel at an incredible rate, shining thousands or even millions of times brighter than the Sun. When they die, they do so spectacularly, exploding as supernovae that briefly outshine entire galaxies. Fact 22. Supernovae are among the most powerful explosions in the universe. When a massive star runs out of fuel, its core collapses in a fraction of a second, releasing more energy in that instant than the star emitted during its entire lifetime. The outer layers are blasted into space at speeds of tens of thousands of kilometers per second. For a few weeks, the supernova can be brighter than billions of stars combined. These explosions scatter heavy elements throughout space, enriching the cosmos with the building blocks of planets and life. Fact 23. A supernova explosion visible from Earth would be an incredible sight. If a supernova occurred within a few thousand light years, it would be bright enough to be visible during the day, casting shadows at night. Fortunately, there are no stars close enough to Earth that pose a supernova threat in the foreseeable future. The nearest candidate, Betelgeuse, is about 550 light-years away, far enough that even when it eventually explodes, it will not harm us. It will simply be a magnificent light show in the sky. Fact 24. Betelgeuse is a red supergiant star nearing the end of its life. It is one of the brightest stars in the night sky, visible in the constellation Orion as the reddish star marking the hunter's shoulder. Betelgeuse has already exhausted much of its fuel and could explode as a supernova at any time, though any time in astronomical terms could mean tomorrow or 100,000 years from now. When it does explode, it will be one of the most spectacular astronomical events in human history. Fact 25. Some stars die quietly. Stars like the Sun do not have enough mass to explode as supernovae. Instead, they swell into red giants, shed their outer layers gently, and leave behind white dwarfs. The expelled layers form beautiful structures called planetary nebulae, glowing shells of gas lit from within by the dying star. These nebulae are some of the most beautiful objects in the sky, with intricate shapes and vibrant colors. Fact 26. Planetary nebulae have nothing to do with planets. The name is a historical accident. When astronomers first observed them through early telescopes, they appeared as round, disc-like objects, similar to how planets look. The name stuck, even though we now know they are the expelled outer layers of dying stars. Despite the misleading name, planetary nebulae are among the most visually stunning objects in astronomy. Fact 27. Stars are born in nebulae, vast clouds of gas and dust. These clouds are cold and dark, shielding their interiors from starlight. Over millions of years, gravity pulls the gas together, compressing it. As the cloud collapses, it heats up. Eventually, the core becomes hot and dense enough for nuclear fusion to ignite, and a new star is born. The process transforms cold, dark gas into blazing light. Fact 28. Stars often form in clusters. When a giant molecular cloud collapses, it typically fragments into hundreds or thousands of smaller clumps, each becoming a star. These stars are born together, siblings sharing the same origin. Over time, gravitational interactions cause the cluster to disperse, scattering its stars across the galaxy. But for a few million years, the cluster remains intact, a family of stars shining together. Fact 29. Our Sun was likely born in a cluster. About 4.5 billion years ago, it formed along with hundreds or thousands of other stars from the same collapsing cloud. Those sibling stars have long since dispersed, scattered throughout the Milky Way by gravitational interactions and the galaxy's rotation. Somewhere out there, distant stars share the Sun's origin, though we may never identify them. Fact 30. Every atom in your body was forged in a star. The hydrogen in your cells was created in the Big Bang, but everything else, the carbon, oxygen, nitrogen, calcium, iron, all of it was made inside stars through nuclear fusion. When those stars died, they scattered their enriched material into space. That material eventually became part of the cloud from which our solar system formed. You are literally made of stardust, the recycled remains of ancient stars. Fact 31. Gold and other heavy elements were created in even more violent events. Elements heavier than iron cannot be produced in ordinary stellar fusion. They require the extreme conditions of a supernova or the collision of two neutron stars. These cataclysmic events produce intense bursts of neutrons that bombard atomic nuclei, building up heavier and heavier elements. Every gold ring, every platinum coin, every atom of uranium was forged in one of these cosmic catastrophes. Fact 32. Neutron star collisions produce gravitational waves. In 2017, astronomers detected gravitational waves from the merger of two neutron stars in a galaxy 130 million light-years away. The collision released more energy than all the stars in the visible universe combined, though it lasted only a few seconds. The event also produced a burst of gamma rays and a kilonova, a bright explosion that scattered newly formed heavy elements into space. It was the first time humanity witnessed the birth of gold and platinum in real time. Fact 33. Gravitational waves are ripples in space-time. When massive objects accelerate, they create waves that propagate through the fabric of space and time itself, traveling at the speed of light. These waves are incredibly faint. Even the merger of two black holes, one of the most violent events in the universe, produces gravitational waves that stretch and compress space by less than the width of an atomic nucleus. Detecting them required some of the most sensitive instruments ever built. Fact 34. The first gravitational waves were detected in 2015. The LIGO observatories in the United States detected ripples from the merger of two black holes over 1 billion light-years away. It was a historic moment, confirming a prediction Einstein made a century earlier. Since then, dozens of gravitational wave events have been detected, opening a new window onto the universe. We can now hear cosmic events that are invisible to telescopes. Fact 35. Space and time are woven together into a single fabric called space-time. Einstein's theory of relativity revealed that space and time are not separate, independent entities, but are unified. Events that occur at different times and places are connected through space-time, and the geometry of space-time is shaped by mass and energy. Massive objects like stars and planets warp space-time, creating what we experience as gravity. Fact 36. Gravity is not a force pulling objects together. It is the curvature of space-time. When you fall, you are not being pulled by a force. You are following the natural contours of curved space-time. Earth curves space-time around it, and objects moving near Earth follow those curves. This is why satellites orbit and why apples fall. They are simply following the straightest possible paths through curved space-time. Fact 37. Time flows differently in different gravitational fields. The stronger the gravity, the slower time passes. This has been confirmed by precise experiments. Clocks at higher altitudes, where gravity is slightly weaker, tick faster than clocks at sea level. GPS satellites must account for this difference. If they did not, the system would accumulate errors of several kilometers per day. Time is not absolute. It is relative, shaped by gravity and motion. Fact 38. If you fell into a black hole, time would behave strangely. From your perspective, falling in would take only a finite amount of time. But to someone watching from a safe distance, you would appear to slow down as you approached the event horizon, never quite crossing it. Your image would freeze, redden, and fade as the light from you became increasingly stretched and dimmed. You would appear to be suspended at the edge of the black hole forever, though from your perspective, you would have already fallen through. Fact 39. Inside a black hole, space and time swap roles. Outside the event horizon, you can move freely through space, but are dragged inevitably forward in time. Inside the event horizon, you can move freely through time, in a sense, but are dragged inevitably toward the singularity. The singularity is not a place in space. It is a moment in time, a moment in your future that you cannot avoid, no matter what you do. Fact 40. We do not know what happens at the singularity. The mathematics of general relativity predicts infinite density and infinite curvature, but infinities usually signal that a theory has reached its limits. Most physicists believe that a theory of quantum gravity, which does not yet exist, will reveal what truly happens at the center of a black hole. The singularity may not be a point at all, but something stranger, something we cannot yet imagine. Fact 41. Black holes may eventually evaporate. Stephen Hawking predicted that black holes emit faint radiation, now called Hawking radiation, due to quantum effects near the event horizon. This radiation carries energy away from the black hole, causing it to lose mass very slowly. Over unimaginable timescales, trillions upon trillions of years, even the largest black holes could evaporate completely, leaving nothing behind. This process is so slow that no black hole in the current universe has lost any measurable mass to Hawking radiation yet. Fact 42. The universe contains vast quantities of invisible matter. This is called dark matter, and it makes up about 85% of all the matter in the cosmos. We cannot see it because it does not emit, absorb, or reflect light. We know it exists only because of its gravitational effects. Dark matter holds galaxies together, shapes the large-scale structure of the universe, and influences how galaxies move and cluster. Despite decades of searching, we still do not know what dark matter is made of. Fact 43. Dark energy is even more mysterious than dark matter. It makes up about 70% of the total energy content of the universe. Dark energy is a kind of anti-gravity, a force that pushes space apart rather than pulling it together. It is the reason the expansion of the universe is accelerating. Distant galaxies are moving away from us faster and faster. driven by this invisible energy embedded in space itself. We do not know what dark energy is, where it comes from, or why it has the strength it does. It is one of the deepest mysteries in all of science. Fact 44. The universe's expansion is accelerating. In the late 1990s, astronomers studying distant supernovae made a shocking discovery. Instead of slowing down, as they expected, the universe's expansion was speeding up. This acceleration is driven by dark energy. The implications are profound. If the acceleration continues, galaxies beyond our local group will eventually move away so fast that their light will no longer reach us. In trillions of years, the night sky will be much emptier, with only the stars of our own galaxy visible. Fact 45. The universe may end in a big freeze. If dark energy remains constant, the universe will continue expanding forever. Galaxies will drift farther apart. Star formation will gradually cease as gas is used up. Existing stars will burn out one by one. Eventually, the universe will become cold, dark, and empty, filled only with black holes, dead stars, and scattered particles. Even the black holes will eventually evaporate through Hawking radiation. In the end, the universe will be a vast, cold void, a state of maximum entropy where nothing can happen anymore. Fact 46. Alternatively, the universe could end in a big rip. If dark energy grows stronger over time, it could eventually tear everything apart. First, galaxy clusters would be ripped apart, then individual galaxies, then solar systems, then planets. Finally, even atoms would be torn apart, as space itself expands faster than the forces holding matter together. This scenario is less likely based on current observations, but it remains a possibility. Fact 47. There is also a scenario called the Big Crunch. If dark energy were to weaken or reverse, gravity could eventually halt the universe's expansion and pull everything back together. The universe would collapse, galaxies merging, space contracting, until everything was compressed into a hot, dense state similar to the Big Bang. Some theories suggest this could lead to a new Big Bang, a cyclical universe that expands and contracts repeatedly. But current observations suggest this is unlikely. The universe seems destined to expand forever. Fact 48. The observable universe contains about 2 trillion galaxies. Each galaxy contains millions, billions, or even trillions of stars. The total number of stars in the observable universe is almost beyond comprehension, perhaps 10 to the power of 24. And each of those stars might have planets. The universe is vast beyond imagining, filled with more worlds than we could ever count. Fact 49. Galaxies come in different shapes. Some, like the Milky Way, are spirals, with graceful arms curving outward from a central bulge. Others are elliptical, smooth and featureless, shaped like footballs or spheres. Still others are irregular, with no clear structure at all. The shape of a galaxy tells a story about its history, how it formed, how it has interacted with other galaxies, and how it has evolved over billions of years. Fact 50. Galaxies collide and merge. Despite the vast distances between stars, galaxies themselves are close enough together that collisions are common over cosmic timescales. When two galaxies collide, their stars rarely hit each other, but their shapes are distorted by gravity. Spiral arms are pulled out into long tidal tails. Gas clouds collide, triggering bursts of star formation. Over hundreds of millions of years, the two galaxies merge into one, their stars mixed together, their supermassive black holes eventually spiraling inward and merging. Fact 51. The Andromeda Galaxy is on a collision course with the Milky Way. These two giant spirals, the largest galaxies in our local group, are approaching each other at about 110 kilometers per second. In about 4 billion years, they will begin to merge. The night sky will transform as Andromeda looms larger and larger, eventually filling the view with its billions of stars. The collision will be slow and graceful, taking hundreds of millions of years to complete. When it is over, the two galaxies will have become one, a giant elliptical galaxy that some astronomers have already nicknamed Milkomeda. Fact 52. Despite the collision, the Sun and Earth will likely survive unharmed. The distances between stars are so vast that the chances of any two stars actually colliding during a galactic merger are incredibly small. Our solar system might be flung into a different part of the new galaxy or even ejected into intergalactic space, but the Sun itself will probably continue shining, and if Earth still exists by then, it will continue orbiting peacefully. Fact 53. The Milky Way has already absorbed many smaller galaxies. Our galaxy has grown over billions of years by cannibalizing its smaller neighbors. Streams of stars orbiting the Milky Way are the remnants of these ancient meals, the stretched-out remains of dwarf galaxies that were torn apart by our galaxy's gravity. This process continues today. The Sagittarius dwarf galaxy is currently being shredded, its stars slowly merging into the Milky Way. Fact 54. The large and small Magellanic Clouds are satellite galaxies orbiting the Milky Way. They are visible from the southern hemisphere as two bright patches in the night sky, like detached pieces of the Milky Way. These irregular dwarf galaxies are much smaller than our galaxy, but they are still impressive, containing billions of stars each. They are close enough that gravitational interactions with the Milky Way distort their shapes and strip away gas and stars. Fact 55. The universe is filled with vast empty spaces called voids. These cosmic voids are regions where very few galaxies exist, enormous bubbles in the large-scale structure of the universe. Some voids are hundreds of millions of light-years across. Between the voids lie filaments and walls, dense regions where galaxies cluster together. This structure is often called the cosmic web, a vast network of matter stretching across the universe. Fact 56. The cosmic web was shaped by dark matter. In the early universe, dark matter clumped together under gravity, forming a scaffolding along which ordinary matter could gather. Galaxies formed where dark matter was densest, along the filaments of the cosmic web. The structure we see today, with its clusters, filaments, and voids, is a direct consequence of how dark matter was distributed in the early universe. Fact 57. Galaxy clusters are the largest gravitationally bound structures in the universe. A cluster can contain hundreds or even thousands of galaxies, all held together by gravity. The Virgo cluster, the nearest large cluster to us, contains more than 1,000 galaxies and is about 50 million light-years away. At the center of most clusters lies a giant elliptical galaxy, often the result of many smaller galaxies merging over time. Fact 58. Galaxy clusters are filled with hot gas. This intracluster medium is so hot, tens of millions of degrees, that it glows in X-rays. The gas is invisible to optical telescopes, but blazes brightly when viewed with X-ray satellites. This hot gas contains more mass than all the stars in all the galaxies in the cluster combined. It is a reminder that most of the ordinary matter in the universe is not in stars, but in the space between them. Fact 59. The universe is isotropic and homogeneous on large scales. This means that if you zoom out far enough, every direction looks the same, and every region of space has roughly the same density of galaxies. On small scales, the universe is clumpy, with galaxies, clusters, and voids. But on the largest scales, spanning billions of light-years, it is remarkably uniform. This uniformity is one of the key observations supporting the Big Bang theory. Fact 60. The cosmic microwave background is nearly uniform. When we map the temperature of this ancient light across the sky, we find that it varies by only about 1 part in 100,000. These tiny variations, called anisotropies, are the seeds from which all structure in the universe grew. Regions that were slightly denser in the early universe attracted more matter, eventually forming galaxies and galaxy clusters. Fact 61. The universe appears to be flat. Measurements of the cosmic microwave background reveal that the overall geometry of space is very close to flat, meaning that parallel lines remain parallel, and the angles of a triangle add up to 180 degrees. This flatness is remarkable. If the universe had even slightly more or less mass and energy, its geometry would be noticeably curved, either positively like a sphere or negatively like a saddle. The fact that it is so flat suggests something special about the initial conditions of the universe. Fact 62. Inflation theory explains why the universe is so flat and uniform. Inflation proposes that in the first tiny fraction of a second after the Big Bang, the universe expanded exponentially, growing from smaller than an atom to larger than a galaxy in less than a trillionth of a second. This rapid expansion smoothed out any irregularities and flattened the geometry of space. Inflation is still a theoretical idea, but it explains many features of the universe that would otherwise be puzzling. Fact 63. The universe may be much larger than the observable universe. Inflation suggests that the universe underwent such rapid expansion that most of it lies beyond our cosmic horizon. We can only see the part from which light has had time to reach us. Beyond that lies more universe, perhaps infinitely more, forever hidden from view. Fact 64. There may be other universes. Some versions of inflation theory suggest that our universe is just one bubble in a vast multiverse, a collection of universes each with its own properties. In this scenario, inflation never truly ends. It continues in some regions, spawning new universes eternally. Each universe could have different physical laws, different constants of nature, even different numbers of dimensions. Our universe would be just one among countless others. Fact 65. We cannot observe other universes. If they exist, they are separated from us by vast expanses of inflating space, forever beyond our reach. No signal from another universe could ever reach us. This makes the multiverse idea controversial. Some scientists embrace it as a natural consequence of inflation. Others argue that if something cannot be observed, even in principle, it is not science but philosophy. Fact 66. The constants of nature seem finely tuned for life. If the strength of gravity were slightly different, stars could not form. If the strong nuclear force was slightly weaker, atoms heavier than hydrogen would not exist. If the cosmological constant related to dark energy were much larger, the universe would have expanded so fast that galaxies could never form. The fact that all these constants have values that allow for stars, planets, and life is striking. Some see it as evidence of design. Others point to the multiverse, suggesting that countless universes exist with different constants, and we simply happen to live in one where the conditions are right. Fact 67. The universe is not infinitely old, but time may have no beginning. Some theories propose that time is cyclical, or that our universe emerged from a previous state. Others suggest that time itself was created at the Big Bang. The nature of time remains one of the deepest mysteries in physics. What we do know is that the universe has a finite age, nearly 14 billion years, and that it has been evolving and changing ever since. Fact 68. Space is not empty. Even the vacuum of space is filled with quantum activity. Virtual particles constantly pop into and out of existence, borrowing energy from the vacuum for brief moments before annihilating each other. This quantum foam is invisible and fleeting, but it has measurable effects. It influences the behavior of particles and may even be related to dark energy. Fact 69. The vacuum has energy. Empty space itself contains energy, a property described by the cosmological constant in Einstein's equations. This vacuum energy may be what we call dark energy, the mysterious force driving the accelerated expansion of the universe. But the value of this energy, as measured by observations, is much smaller than quantum theory predicts. This discrepancy, known as the cosmological constant problem, is one of the biggest unsolved mysteries in physics. Fact 70. The early universe was incredibly hot and dense. In the first moments after the Big Bang, temperatures were so high that matter as we know it could not exist. Instead, the universe was filled with a soup of fundamental particles and radiation, all in thermal equilibrium. As the universe expanded and cooled, particles began to combine. Quarks formed protons and neutrons. Protons and neutrons formed atomic nuclei. Eventually, atoms formed, and the universe became transparent to light. Fact 71. The first atoms were hydrogen and helium, about 75% hydrogen and 25% helium, with tiny traces of lithium. These are the simplest elements, and they were forged in the first few minutes after the Big Bang in a process called Big Bang nucleosynthesis. Every other element, everything in the periodic table from carbon to uranium, was created later inside stars. Fact 72. The first stars were very different from stars today. Called population 3 stars, they formed from pristine gas containing only hydrogen and helium. Without heavier elements to help cool the gas, These stars were likely enormous, perhaps hundreds of times more massive than the Sun. They burned brilliantly and briefly, living only a few million years before exploding as supernovae. Their explosions scattered the first heavy elements into space, enriching the gas from which the next generation of stars would form. Fact 73. We have never seen a population 3 star. They all died billions of years ago. But astronomers are searching for them with powerful telescopes like the James Webb Space Telescope, looking at the most distant, earliest galaxies, hoping to catch a glimpse of these ancient giants or the afterglow of their explosions. Fact 74. The James Webb Space Telescope can see farther into the past than any telescope before it. By observing in infrared light, it can detect galaxies whose light has been traveling for more than 13 billion years. These galaxies appear as they were when the universe was only a few 100 million years old, giving us a window into the cosmic dawn, the era when the first stars and galaxies were forming. Fact 75. The most distant galaxies are moving away from us faster than the speed of light. This does not violate relativity, because it is space itself that is expanding, carrying the galaxies with it. The galaxies are not moving through space faster than light. Space is simply growing between us and them. This expansion can happen at any speed. There is no limit to how fast space can expand. Fact 76. Some galaxies are so distant that their light will never reach us. Because the universe is expanding and the expansion is accelerating, there is a cosmic horizon beyond which galaxies are receding faster than light can travel toward us. Their light is being swept away by the expansion of space, and it will never close the distance. These galaxies are forever beyond our view, even in principle. Fact 77. The night sky is dark because the universe is expanding. This may seem obvious, but it is actually a profound observation known as Olbers's paradox. If the universe were infinite, eternal, and static, every line of sight should eventually intersect a star, and the night sky should be blazing with light. The fact that it is dark tells us the universe is not static. It had a beginning, it is expanding, and distant light has not had time to reach us. The darkness of the night sky is evidence of the Big Bang. Fact 78. Stars twinkle because of Earth's atmosphere. The light from stars is disturbed by turbulence in the air, causing their brightness to fluctuate. Planets, on the other hand, do not twinkle as much because they appear as tiny disks rather than points of light. In space, above the atmosphere, stars do not twinkle at all. They shine steadily, unwavering. Fact 79. The Sun is a yellow dwarf star, though it looks white from space. The atmosphere scatters blue light, making the sky blue and the Sun appear more yellow when viewed from the ground. But if you could see the Sun from space without filters, it would appear white, a balanced mixture of all colors of light. Fact 80. The Sun loses 4 million tons of mass every second. This mass is converted into energy through nuclear fusion, following Einstein's famous equation, E=mc². Despite losing this much mass, the Sun is so large that it will be able to continue fusing hydrogen for another 5 billion years before it begins to run out of fuel. Fact 81. The Sun is located in a relatively quiet region of the Milky Way. We orbit in what is called the Orion Arm, a minor spiral arm situated between two major arms of the galaxy. This location is neither too close to the chaotic galactic center, nor too far out in the sparse outer regions. It is a calm, stable neighborhood, one where life has had billions of years to evolve without major disruptions. Fact 82. The Sun orbits the center of the Milky Way at about 800,000 kilometers per hour. Despite this incredible speed, it takes about 225 million years to complete one orbit. This journey around the galaxy is called a galactic year. In the time since dinosaurs walked the Earth, the Sun has barely moved a fraction of the way around its orbit. The cosmos operates on timescales far grander than our own. Fact 83. The planets in our solar system all orbit in nearly the same plane. This flat disk structure is a remnant of the way our solar system formed. About 4.5 billion years ago, a rotating cloud of gas and dust collapsed under gravity. As it collapsed, it flattened into a disk, and within that disk, planets formed. The orbits of the planets today still reflect that original disk structure. Fact 84. The asteroid belt lies between Mars and Jupiter. It contains millions of rocky objects, remnants from the early solar system that never coalesced into a planet. Jupiter's powerful gravity stirred the region, preventing the asteroids from gathering together. Instead, they remain scattered, a cosmic rubble field orbiting the Sun. Fact 85. Jupiter is the largest planet in our solar system. It is so massive that it contains more than twice the mass of all the other planets combined. Jupiter is a gas giant with no solid surface. If you could somehow descend into Jupiter, you would pass through layers of hydrogen and helium, sinking deeper and deeper until the pressure became so intense that hydrogen transitions into a metallic state. At the very center, there may be a core of rock and ice, but we are not certain. Fact 86. Jupiter's Great Red Spot is a storm larger than Earth. It has been raging for at least 350 years, perhaps much longer. This giant anticyclone is slowly shrinking, and some astronomers predict it may disappear within the next few decades. But for now, it remains one of the most iconic features in the solar system, a swirling red eye staring out from Jupiter's clouds. Fact 87. Saturn's rings are made mostly of ice. They are beautiful and delicate, stretching hundreds of thousands of kilometers across, but only about 10 meters thick in most places. Despite their appearance, the rings are not solid. They are made of countless individual chunks of ice, ranging in size from dust grains to boulders. These particles orbit Saturn in a vast flat disk, creating the illusion of solid rings when viewed from a distance. Fact 88. Saturn's rings may be relatively young. Evidence suggests they might have formed only a few 100 million years ago, perhaps from a moon that wandered too close and was torn apart by Saturn's gravity. If so, we are living in a brief cosmic moment when Saturn wears this spectacular crown. In another few 100 million years, the rings may be gone, fallen into the planet, or scattered into space. Fact 89. Uranus rotates on its side. Its axis is tilted 98 degrees, meaning it essentially rolls along its orbital path rather than spinning upright like most planets. This extreme tilt may have been caused by a massive collision early in the solar system's history. The result is that Uranus experiences extreme seasons. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness. Fact 90. Neptune is the windiest planet in the solar system. Despite being the farthest planet from the Sun and receiving very little solar energy, Neptune has winds that reach speeds of over 2,000 kilometers per hour. The source of this energy is a mystery. Neptune radiates more heat into space than it receives from the Sun, suggesting it has an internal heat source, but we do not fully understand why. Fact 91. Pluto is no longer classified as a planet. In 2006, the International Astronomical Union redefined what it means to be a planet, and Pluto did not meet the criteria. It is now classified as a dwarf planet, one of many small icy bodies orbiting in the Kuiper Belt beyond Neptune. This decision was controversial, but it reflected our growing understanding that Pluto is just one member of a large population of similar objects. Fact 92. The Kuiper Belt is a region of icy bodies beyond Neptune. It is similar to the asteroid belt, but much larger and more distant. The Kuiper Belt contains millions of objects, including dwarf planets like Pluto, Eris, Makemake, and Haumea. These frozen worlds are remnants from the solar system's formation, preserved in the cold outer reaches where the sun's heat is faint. Fact 93. Beyond the Kuiper Belt lies the Oort cloud. This vast, spherical shell of icy bodies surrounds the solar system, extending halfway to the nearest star. The Oort cloud is thought to contain trillions of comets, icy remnants left over from the solar system's formation. Occasionally, a passing star or gravitational disturbance nudges one of these comets inward, sending it on a long journey toward the Sun. When it approaches, the Sun's heat vaporizes its ice, creating the glowing tail we see from Earth. Fact 94. Comets are often called dirty snowballs. They are made of ice, dust, and rock, remnants from the early solar system. When a comet approaches the Sun, the ice sublimates, turning directly from solid to gas and releasing dust. This creates a glowing cloud around the comet called a coma, and a tail that can stretch for millions of kilometers. The tail always points away from the Sun, pushed by the solar wind and radiation pressure. Fact 95. Some comets have very long orbital periods. Halley's Comet returns every 76 years, but others take thousands or even millions of years to complete one orbit. These long-period comets come from the distant Oort cloud, swinging in toward the Sun, and then retreating back into the depths of space. Some comets are on such elongated orbits that they will not return for hundreds of thousands of years. Fact 96. Meteors are not stars. They are small pieces of rock or dust burning up in Earth's atmosphere. When these particles, often no larger than a grain of sand, enter the atmosphere at high speed, friction heats them to thousands of degrees, causing them to glow briefly. We call these streaks of light shooting stars, though they have nothing to do with actual stars. Most meteors are fragments from comets or asteroids. Fact 97. Meteor showers occur when Earth passes through the debris trail of a comet. As comets orbit the Sun, they shed dust and small particles, leaving a trail along their path. When Earth's orbit intersects one of these trails, we see a meteor shower, dozens or even hundreds of meteors per hour streaking across the sky. Each meteor shower is associated with a particular comet. The Perseids come from Comet Swift-Tuttle. The Leonids come from Comet Tempel-Tuttle. Fact 98. A meteorite is a meteor that survives its journey through the atmosphere and reaches the ground. Most meteors burn up completely, but larger pieces can make it through. Meteorites are valuable to scientists because they are samples of asteroids and other solar system bodies delivered to Earth for free. By studying meteorites, we can learn about the composition and history of the early solar system. Fact 99. The Moon is slowly drifting away from Earth. Tidal interactions between Earth and the Moon cause the Moon's orbit to expand by about 3.8 centimeters per year. This process has been going on for billions of years. In the distant past, the Moon was much closer to Earth. Days were shorter, and the Moon appeared much larger in the sky. In the distant future, the Moon will be farther away, appearing smaller, and Earth's rotation will have slowed even more. Fact 100. The Moon was likely formed from a giant impact. About 4.5 billion years ago, a Mars-sized object called Theia collided with the early Earth. The impact was so violent that it vaporized rock and sent massive amounts of debris into orbit around Earth. Over time, this debris coalesced into the Moon. This theory, called the giant impact hypothesis, explains many features of the Earth-Moon system, including why the Moon has a small iron core and why its composition is similar to Earth's mantle. And now you have drifted through 100 facts about the cosmos, 100 glimpses into the vast, beautiful, mysterious universe that surrounds us. Each fact is a doorway, an invitation to wonder, but tonight they are something more. They are gentle weights pulling you deeper into rest, reminders that you are part of something ancient and enormous, something that has been unfolding for nearly 14 billion years and will continue long after you close your eyes. The cosmos does not ask for your attention. It simply exists, patient and eternal. Stars are born and die, galaxies collide and merge. Black holes spin in silence. Space expands, carrying everything with it, and through it all, time flows forward, indifferent and unstoppable. You are here now. A brief spark of consciousness in the midst of it all, aware, awake, and yet ready to let go. Let your body grow heavy. Let your breathing slow. Imagine yourself floating through space, weightless and calm, drifting past stars and nebulae, galaxies and clusters, moving through the darkness with no effort at all. There is no destination. There is only the journey, gentle and endless, carrying you deeper into rest. You do not need to hold on to anything. Not the facts, not the numbers, not the names. They have served their purpose. They have filled your mind with wonder, and now they can fade, dissolving like mist in the morning sun. What remains is the feeling, the quiet awe, the sense that you are small and yet connected, a single note in the cosmic symphony. The universe is still here, still expanding, still shining. But you do not need to watch it tonight. You can rest, you can let go. You can drift into sleep, knowing that tomorrow the stars will still be there, waiting, eternal and patient, as they have always been. So close your eyes if you have not already. Feel the gentle pull of sleep, like gravity, like the slow expansion of space, carrying you forward into the dark. There is nothing to resist, nothing to fear, only the soft, quiet embrace of the cosmos, holding you as you fall into dreams. And if you are still awake, still listening, that is fine too. You can stay here as long as you like, floating through the facts, through the stars, through the endless night. But eventually, without even noticing, you will cross the threshold. You will slip into sleep, and when you do, the universe will still be here, watching over you, vast and beautiful, and filled with mysteries you can explore another night. For now, there is only this, the darkness, the quiet, the slow, steady rhythm of your breath. And somewhere, far above, the stars shine on, distant and serene, lighting the cosmos with their ancient glow. Rest now. Let the universe carry you. Drift into sleep, into dreams, into the gentle dark. And know that you are part of something extraordinary, something that began with the Big Bang and continues still, unfolding across billions of light years. A story written in starlight and time. Good night. Sleep well. And may your dreams be filled with wonder, with galaxies and stars, with the quiet beauty of the cosmos stretching out forever into the dark.